Hi there folks, and welcome to another EMF Informer report. My name is Seth, and today I'm here to guide you through the ins and outs of EMF as it pertains to mobile phone masts, or cell towers as they're often called. So we have many more upcoming videos on various EMF subjects on their way, so please do leave a like and subscribe to the channel so you don't miss those. And in this video today, I am going to take you through the various types of antennas used on the various masts, the different ways in which they get the signal to your phone, and the EMF power intensities that we would expect to receive from them at different ranges and in different scenarios. Also looking at why they are made up into cells, what the angles and beam widths these masts utilize, as well as a bit of background and maths, of course, and science, which you can skip through very easily if that's not your thing, so don't worry about that. So this video is likely going to be pretty useful for the following 4 categories of viewers. So we have electro-hypersensitive sufferers, mobile data users who need to know where they would get the best signal, so on, those who are trainee surveyors in the EMC, EMF fields, and generally folks concerned about 4G and 5G, how it might affect us, what the intensities are in the different areas from the different masts. This is for you. We will be covering everything today in this video. Now, some of you may be asking, so who are these electrosensitive sufferers, and why are they and others so concerned about mobile phone masts these days? Well, the issue really is that the government safety guidelines, especially here in Britain, as set out by the EIRP body, these guidelines are already 50 years out of date. They have not been updated in that time, really. They have been widely debunked as both scientifically and medically invalid now, providing really no protection against a range of modern conditions, including cancers. It's all out there, folks. The research is there. Google is your friend. So, for example, the guidelines that we are given in Britain say that 61,000 millivolts per meter is fine for the public. Contrast this with a large study done by the European Parliament 10 years ago, where they looked at a lot of research, they looked at studies, they did their own studies, and found that actually a safe guideline for EMF exposure is actually about 200 millivolts per meter during the day and about 62 millivolts per meter at night. So a big difference between different sets of guidelines. If you look at countries in Europe, some of them such as Belgium, Austria, Russia, their guidelines are actually 6,000 millivolts per meter. Compare that to 61,000 in Britain, you can see that there are a lot of different safety levels. They widely vary greatly. So, what are they? Cell towers, mobile phone masts, lots of different names for them. Typically 12 to 30 meters high. You've all seen them. They are around the countryside, in the towns. You may see very tall telecoms towers, which can be 240 meters. These obviously have a much greater range. Each of these masts or towers will typically have several antennas on them. typically 3 antennas, could be up to 15. Some of them may be just a single monopole antenna. So let's look at where these are typically located now. So as we see, the picture here, you have the large telecommunications array, very tall, big distance between each one. Then you have your usual macro cell masts. These are usually a few miles apart. And of course, our micro cell masts, which are more popular in urban areas. You can see a picture of one on the right there. Let's take a look first at macro cells. These were traditionally the most common type of mast around Britain especially. Now they're more often found in rural areas. As you can see, some of them, they might only have about 3 antennas to cover 3 directions. But in the picture here, you can see more typically nowadays, operators are sharing the same masts. So in this one in the picture, that's probably 3 different operators using the one mast. So for example, it could be Vodafone at the top, O2 in the middle, and EE or T-Mobile at the bottom. These are called sectored masts because each of those antennas covers a sector about 120 degrees wide on the horizontal, and of course the 3 sectors together make up the 360 degree coverage all around. They have a very narrow vertical beam, so bear this in mind. If you're under one of these masts, there won't really be much signal for about another 400 meters until you move away from it, because the beam is high and it's a very narrow beam in the vertical angle. So we can see typical power here is very important. The number of watts the tower is rated at will have a great effect on the range it has and the amount of power you would pick up on your phone or meter at a specific distance. And as you can see, these towers have a maximum range of 15 kilometers, although generally they won't be covering more than about 7 miles at the most. Okay, moving on to microcells, which are these funny telephone pole type things you see around urban areas. They are much smaller and they are also less powerful than the macro masts because they're designed to have a much shorter range, about 1 kilometer, but have more of them. So they're spread closer together, there are more of them, and they are called omni antennas because it's just one antenna that transmits in a full 360 degree field. Therefore, they have less gain, they're not so directional, and again, they have a much lower power, typically 2-5 watts, something like that. They may also have a higher frequency because they don't need to go so far. Okay, so moving on to the smallest kind of antennas, and these are usually not on masts. These are called pico-cells or femto-cells. You're more likely to find these in shopping malls or sports centres or public places, maybe like stadiums. They have a very short range, as you can see, a little bit more than a typical Wi-Fi, about the same power as a Wi-Fi transmitter. And they, again, can go up to a higher frequency. Now, I've put this slide here for folks just to get a background on the measurement systems we're going to be using. Obviously, you can just skip this slide if you're not interested in it. I'm going to move on quickly, but this is useful stuff you need to know. And again, understanding dBi gain is a very important aspect along with transmit power because each mast is going to have a rated power which will be maybe in dBW, it might be in dBm, it might be in watts, but they will also have a dBi gain for the antenna. So it's very important not to confuse these. dBi gain is how directional the antenna is. So if it has a high gain, it means that it will have a narrower beam, something like this perhaps. If it has a small gain like 3 decibels or 5 decibels, then it might have a full 360-degree angle. So please do educate yourself on that as well. It's a very important aspect. So talking about the gain, we need to look at the angle of these antennas, which is quite critical and important to understand when you're looking at where a mast is and working out what kind of signal you're going to get on your mobile phone, depending on where you are in relation to that mobile phone mast. Now, as you can see, with the macro-cell masts that you find more in the countryside have the 3 horizontal sectors. Sometimes there might be 6, as you can see in the picture on the bottom left there. As you can see, each sector is about 120 degrees wide. But if you look at the middle picture here, you can see that as the beam, the signal beam, leaves the sectored antenna, it has a very narrow angle in the up and down. So you can see it's a very narrow beam there. That's only about 5 degrees, maybe 10 degrees, which is designed to cover a particular kind of cone-shaped area on the ground over half a mile away, some miles away. So exactly under the mast, there will be very little signal at all. If we look at microcells on the right here, you have the elevation pattern there. As you can see, they're more like about 20-30 degrees vertical angle. But if you look at the bottom right there, the colourful 3D pattern, it shows that they radiate outwards on the horizontal plane in 360 degrees. A bit like a donut as the field spreads outward. You can see the picture of the mast there. So if we were looking down on the map at an antenna in the top of the map there, you can see the way it might spread out from the antenna. This one's actually a 90-degree sector. And you can see the red area is a strong signal, with the orange area being perhaps 3 decibels lower signals. That might be half as much. And then the yellow area, again, that might be a few decibels less again. So that might be only a quarter of the signal strength of the red area. Now you can see it would be a cone shape if this was a flat terrain, but in this part of Wales there's a lot of hills there, and hills are very good at blocking the signal. So wherever there's a valley behind a hill, that receives no signal at all, and we call that a dead zone. Looking on the picture on the right here, we're looking down at a 120 sector. So this is one of those white vertical strip patch array antennas that we see on a macro cell, and you can see the cyan area is the coverage going out from the mast, but the red is particularly strong power, the yellow a bit less strong, the green would be a good signal on the phone, and then the blue area might be 2 bars, for example, on the mobile phone. So this is an actual coverage map that I've made of a particular area in West Wales. So this shows the live mobile phone masts in red, the red dots there. And we've actually used a ray tracing model to plot the rays out from each mast, showing where it would actually cover. So you can see in these very hilly areas, we can see the white areas. That is where there would be almost no signal, mostly in valleys, as you can see. And then up on the hills, there's very good signal, as you can see the pink area and the orange area. So you can see in a rural area, these macro cell masts are roughly 3 miles apart. Now let's compare that to a city. So this is the city of Bristol, and this is roughly the same sort of area shown on the map. But as you can see, the masts are much denser together. Most of these would be microcell masts with a much smaller power. So these masts might typically only be about 5 to 10 watts. Compare that to the macrocell masts in the previous slide, which would have been 20 watts, perhaps even 30 watts in power. So these masts have a much smaller range. Each one only needs to go about 500 meters. So they're typically about 350 meters apart there. So you can see a completely different model in the city than you would have in the countryside. So very briefly, each mast obviously has a duty cycle, which is how much of its maximum time it can be transmitting. So do have a look at that slide to get an idea of how the amount of power being given out by the mast constantly changes depending on the load of the mast. And the key thing here is that in rural areas, you're likely to get higher peak measurements in millivolts per meter, whereas the actual constant output is likely to be higher in towns. So you get more of a cumulative dosage in the towns, but lower peak values. Now, when we look at actual powers that you would detect on a meter, for example, at a certain distance from a mast, it's very important to bear in mind that this can be mathematically calculated. But we must remember that signal power transmitted from an antenna on a mast does not decrease in intensity in a linear fashion. So if you're twice as far from the mast, that doesn't mean that the power is going to be half as much. In actual fact, it's going to be 4 times less, because we use the inverse square law to calculate this. You can see in the picture on the right here that the signal is actually having to expand into a much larger area in both X and Y axis. And this is why it's actually decreasing much faster than we would expect in intensity. So do look at the example there. As you can see, a mast 300 meters away actually has 9 times lower intensity of EMF than a mast 100 meters away. So do bear that in mind. Now, you can see the technical specification for a mast sometimes on an operator's website. It might give you a value like 27 dBW, for example. But bear in mind that they don't always transmit at the maximum power they're licensed for, because they do use a lot of electricity. So the masts will generally transmit at the lowest power that they can for you to get a good signal on your mobile phone. So, at 1,000 meters range here, the mast doesn't need to use the full 33 watts that it might be licensed for. It might actually only need 10 watts to be able to get the signal to your mobile phone at a good signal strength. So do bear that in mind as well. So people have asked me, how do we match up the signal powers that a mast is rated for, the antenna on a mobile phone mast, with what a mobile phone actually needs to receive to have a good signal, to download lots of data, to have a good quality telephone call. And so here we can see on this slide that if you're on a 3G network, which is more likely to be in very rural areas, you can see that on your phone you would need to have about -70 dBm for an excellent signal, right down to -109 dBm, which would be a really poor signal. So we have this range. The range is a little bit different for 4G, which is this new LTE technology, and that's about 20 decibels different. If you have a phone, you can actually go into the settings of your phone and actually see the dBm value of the signal strength that you've got. So this will be a much more accurate indicator of how much power you're receiving from a mast than those bars that you see at the top of the phone. So do Google that, because these dBm values are much more accurate, and we can actually use them to compare EMF signal levels. So here I've just shown for you a typical scenario for a mobile phone mast with a particular range. With mathematics, we can actually calculate what the signal strength will be at a particular distance from a mast, but it depends a lot on the weather and the obstacles. This really is the biggest decider of signal strength from a mast, because I mean, these masts could get to your phone over 15 miles on a clear day in a line of sight, and it would be no problem. What is the issue is when you've got mist, when you've got rain. Usually there are trees in the way, there could be a wall of the house, cars, you could be inside the car. All of these things reduce the signal strength by the greatest amount. I mean, we're talking about 6 decibels, perhaps 9 decibels loss in signal strength. As we can see on the next slide, this is the same scenario, but with bad weather and obstacles. And you can see that the phone and the mast need to transmit at a considerably higher power, I mean, twice the amount of power, to achieve the same quality of connection, whether it be data or voice call. So do have a look there. The maths is all there for you. So pause that, check it out. I'm going to move on quickly though, and just have a look at actual live measurements made by us using a top-of-the-range industry spectrum analyzer with very high-quality calibrated antenna. And we've actually tested a number of different macro-cell and micro-cell masts, mostly in a rural area. So this doesn't really reflect inner city measurements. So have a look at this, and you can actually see that this is actually a microcell. The highest signal strength there is at very close range. So range is the key thing. If you're very close to a microcell mast, you can expect a strong output power, a strong received power on the meter. But notice in red, I've marked the one where it's actually much further away than the other masts, but it's got a much higher transmit power. So you also need to look at the transmit power as well as the distance, because if it's got a high transmit power, then even relatively far away, it could have a significant signal strength, whereas masts very close, but with a very small transmit power, again, will be relatively low received power. Okay, so following on from the previous slide, let's just have a look at an actual live trace made using the erroneous spectrum analyzer that we have here. This is sitting on a hilltop with an omnidirectional antenna, so that's 360 degrees, and we're actually picking up about 3 or 4 different mobile phone masts in all directions here. You can see it starts from around 800 megahertz in the top left there, which is the strongest signal. And that's going up to 40, 50 millivolts per meter. Then we're sort of moving across. Then we've got the next band, the GSM band here, which is around 900, 950 megahertz. So you can see that one in the middle. Then you've got a lot of small purple peaks here. That's actually transponders from aircraft picking up there, so that's not part of the mobile network. Then we have a long range that is just not being used out here where we are now. Then we've got the 1700 megahertz range, which is fairly active, as you can see there. And then the main range here, which is the 1800 megahertz in the bottom right here, where you can see the blue is showing the actual average constant emissions, and the purple is showing the maximum peaks. So that's what it looks like in an actual live trace, watching the signal as it's coming in from different mobile phone masts. Okay folks, so I've said this before, it really is about location, location, and location. Where you are in relation to a transmitting device, whether it be a mobile phone, a Wi-Fi transmitter, a laptop, cell tower. If you are very close to that device, you can expect to have an enormous EMF dosage. If you are relatively far away, that EMF dosage will rapidly drop off to very little. I've given some examples here. You can see that a mobile phone mast 1 mile away, giving out 20 watts of power, you're only going to detect about 100 millivolts on the meter or the spectrum analyzer. Compare that with your mobile phone, which is only transmitting 1/4 of a watt at the most, and usually half of that. But you are holding it 25 centimeters from your head. You can be expecting an EMF dosage into your body of thousands of millivolts. Close to your head, it would be over 10,000 millivolts per meter. So that's 2 orders of magnitude higher than a mobile phone mast 1 mile away. So it really is about how close these things are to you. If you have a Wi-Fi router sitting on the desk near you, it's going to be at least 700 to 1,000 millivolts per meter, which is going to be much higher than a mobile phone mast. Right, now I've been asked about cells. Why are they called cell phones? Why are they called cell towers? And this is because a particular geographic area is divided up into these cells, which we represent with these polygons. As you can see, an area is divided up into a lot of cells, and each cell is served by a cell tower. Now, the key thing here is that the masts mustn't interfere with each other. So you can't have one powerful mast covering 5 of these cells, and then another mast also covering cells, and you would have a very poor reception on your phone. So what the mobile phone companies do is they actually use frequency diversity to try and keep neighboring cell towers in a completely different frequency range, thus reducing this interference. So we can see here the pink ones, A1, you can see they're spaced with a couple of other mast cells between them, and the same with B1. B1 will be on a completely different frequency to A1, and B1 itself is separated by several other cells. And again, you've got frequencies for upload, which is what the mobile phone is transmitting to the mast, and then you've got a different frequency for download, which is what the mast is transmitting to the phone. So bear these in mind when you're testing on your meter. You're going to get very different frequencies depending on whether you're actually detecting the mast or the mobile phone. And this helps you to determine whether it is a phone or a mast that you're picking up. Okay, so let's just quickly go through a few misconceptions that I've noticed when I've had people asking me about these things. So when a mobile phone mast has its output power given in dBW, it's probably a big number like 27, 30, maybe 32. This is actually the EIRP value, which is a theoretical value that the mast would need that much power if it was transmitting 360 degrees. So bear in mind, it's not actually outputting that kind of power. It's actually outputting around 20 or 30 watts. Okay, urban masts do not put out the same kind of power as rural masts. Their power is going to be far less, around 2 to 10 watts typically. So bear that in mind, because there are more of them, but they don't have to transmit so far. So they have a much smaller range. Now, I've had people very concerned about mobile phone masts, asking me, oh, how dangerous are these? And people get concerned more about the masts than the actual devices in their own home. So just bear in mind that your mobile phone or your Wi-Fi router in your house or your portable deck phone in your house is far more of a concern to people's health. They're giving out far higher dosage levels than you're likely to receive from the mast. So yes, masts are a concern for health for some people, particularly those with a low constitution, but the mobile phone is going to have a far greater effect on the human body. Now, people have noticed that there are a lot of new masts going up, especially in urban areas. Lots of new small micro-cell masts being put up everywhere. This is going to certainly increase the kind of electrosmog, if you like, in the area. The general EMF level is going to be constantly higher the more masts are put up, but not necessarily higher peak values. So a lot more microcell masts may actually be less peak powers than in the older 3G networks, where we saw typically macrocell masts transmitting at higher powers because they needed to cover a much greater range. So to close, I'd like to point out that it is very comparative. It's very important to compare mobile phone masts with all of the other transmitting devices that you will typically come into contact with during daily life. So do have a look at the comparison I've put down here, and note, if you're quite far from a mast, you're in a rural area, it may only be 5 or 10 millivolts per meter. If you're in the city and you're very close to the mast, it may be up to 450 or even 500 millivolts. But just bear in mind the devices in your own home are likely to be giving out more than this by many times, especially the mobile phone and especially the deck phone. Microwave oven at 2 meters from it would be giving out roughly 10 times more EMF energy than a mobile phone mast. So it is all comparative, and distance is key, folks. The further you are away, the much lower the signal will be. So I hope that has been very useful. Please do ask any questions in the comments below. Leave a like. Please do subscribe, because there will be many more videos on EMF topics and measurements and typical dosage levels coming in the near future. So from us at EMF Informer, goodbye for now.